Hello. We're in lockdown Mark 2. I suppose I'm the only person in the world who doesn't mind about lockdowns. As I see it, the main advantage of lockdowns, it provides me with a first-class excuse for not attending all kinds of social events that I would otherwise be forced to attend, and I can get on with some work. So last time Dick had made a suggestion that we might be able to measure the position of the rudder shaft using a linear Hall effect sensor. He made that suggestion in good faith, but I tested it out and discovered that it's not satisfactory for measuring positions over a 90-degree angle, which in other words plus or minus 45 degrees from central rudder. I'll put maybe a separate video up about why that is not the case. So I've gone back to my original idea, which is to use a Bourns EMS22A absolute angle sensor. This is a tiny unit. It costs about £60, but it measures the angle to about 1/3 of a degree and works over 360 degrees and will run up to 50,000 RPM, I think. Not that we needed to do that. So this video is about how I connected that angle sensor into the rudder servo equipment so as to measure the angle accurately. So I've got to put it somewhere like that and transfer the rotation from here to there. So my idea was I would take these Delrin gears, put them like that, then we can have this with a suitable bush to enlarge that. I'm thinking that will work. Well, I've been wondering how to fix this Delrin cog to the 6mm shafts. Basically had three options. Evidently you can't Loctite it because Delrin just doesn't stick to anything. I could put a split pin in, or I think this is called a roll pin. It's sprung. But the solution that I think I will try is this. I've just tried it on a scrap piece of Delrin here. This is a taper, metric taper pin, 2mm taper pin, so it goes from 2mm there to something 2.6mm at the other end. And I've got a 2mm hand reamer to make that taper. And that seems to make a very firm connection. So that's what I intend to use on the top of here to fix this there. The other one is I don't have the same choice because this spindle here on the rotary angle sensor is 1/8 of an inch, and clearly you can't put a pin of any kind through it. So I made up a little stainless steel bush that fits on there nicely, and well, the sod is my... I put an M3 grub screw through it, so I think that's going to be quite okay, and it doesn't run eccentrically at all, so that's okay. I'll probably put a blob of araldite or something on the outside of this just to stop it from coming loose. Well, I can just come down like that. This is a 2mm end mill, and I'm just going to drill through the stainless steel that way. that's going to do it. Right, so now I'm just going to drill through the dowel ring. Now we have to switch to a 2mm drill because that end mill isn't long enough to go right the way through. Drill through the bottom part of the dowel ring. That's it. Right, so now we're just going to ream this. As it's 316, we're not taking any chances. We just have to keep going at it until it gets far enough through. Not quite far enough yet. How about this? Yeah, I think that's going to be okay. What I actually want to do is to tap it in a bit. Well, that's absolutely rigid. So let's see if this is straight. I think it's straight. Good. So I'm going to do a bit of final assembly here of this block, which I have degreased with acetone. So this is the front. Let me get this right. Front, left, right, and back. It's got to go like that. Not quite sure how I'm going to apply this. Yeah, all right. This is a lint-free thing here. Of course, this evaporates very quickly, isn't it? How do I get a uniform and appropriate amount on here? That doesn't seem to be the right way to do it. I can do it like this. That's got to go on there. This is not as easy to assemble as I thought. Goes like that. So we need it all along here. Well, bit of a mess where it's squeezed out, but I'm just going to let it set now, and we'll see what's it like tomorrow morning. Well, I've just kind of carried out the final assembly of this gearbox. It's one of those things that's got to be done in exactly the right order, otherwise it doesn't work. And I filled it with oil, well, almost filled it with oil. And the final thing was to put Hylamar all the way around here, blue Hylamar, and do up these screws. And as you can see, 90% of the Hylamar has squeezed out, which is good. It just shows it's a precision fit. But I just hope that there's enough there to stop the oil leaking out. So I'm going to leave it now, maybe put it on its side like this, leave it overnight and see what happens. Right, well, I spent the whole day fiddling with this to mount this Bourns absolute angle sensor in the right place to engage with this gear. So I think that's all right. Obviously it's very, very light load anyway, but the gears seem to be in line and meshing properly. I think that is satisfactory. All I have to do now is find some space to fit the electronics in. I suppose it can go here. So the thing is full of oil, and it's been like that for 2 days, and there's no leaking so far. I'm glad to say that there is no backlash in these gears, or none to speak of. The taper pin is working well to fix this gear on, and this one is fixed on with a set screw, which I haven't yet Loctited in, but anyway, and the gears are well meshed, so no, we're not going to get a backlash error.